you don't like my grading, then no. I try to be fair, but I'm also not the easiest grader in the world. This should be Blackboard bold N, but we'll talk through it. So double sequence is pretty much exactly what you would imagine. It's a sequence that has two inputs, right? So you can write it as sort of like a matrix, but that has infinitely many rows and columns. Those would be like your A11, A12, A13, A21, 22, Q3, and it's going off infinitely in each direction. A32, A33. Sort of an infinite matrix. And I mean, like, really, you can think of it, like we said, with normal sequences, you can think of the sequence as a function from n cross n to r. That's pretty much it. Like, it's exactly what you would think. Double limit is, so there's different kinds of ways you can do limits is probably where I should start. It's not quite as straightforward as normal sequences. So double limit is, usually, I guess, there's a couple ways to denote it. You can denote it as nm approaches some limit L as that pair approaches infinite, which is, I think, how I wrote it. Yeah. And definitionally, that's pretty much what you would expect. For all epsilon, there exists an n, it's just an n, yeah. Exists an n such that for all n and m that are greater than or equal to that n, the absolute value of a n m is minus L is less than epsilon. It's pretty much exactly what you would think for double limit. So then we have proper divergence. So we say that a double sequence is properly divergent if the limits are plus or minus infinity. Oh, sorry, the double limit is plus or minus infinity. Now you could imagine a case where it's not quite as clean cut, right? In that case, maybe it's oscillating, or one thing's going to infinite, but the other is not, right? So there's sort of other cases where it's not. That's why we use the word proper divergence, right? Because it could be sort of improper divergence. We define two iterated limits when they exist. So that's a double limit. Iterated limit is the limit as, well, there's two of them, n approaches infinite, of the limit as m approaches infinite of a n m. That's one of them. The other one's just the opposite. And it turns out they're actually different. They could be the same. And that could also be different than these. So sort of be careful. Yeah, and then it sort of defines it there, right? So it says that if you fix an n, so the first one, if you fix an n, the limit as n goes to infinity of a n n exists. For each fixed n, call that limit b, and then take the limit as n goes to infinity of b and get L. So it's like a sequence of limits. There's a proof for uniqueness of double limits. And then there's an equivalence theorem for double sequences. So we have this be a double a n m be a double sequence. If the limit exists for all m, then the limit as n goes to infinity of a n m exists. And for each n, the limit as m goes to infinity of a n m exists. Then both iterated limits exist and equal L. So sort of three conditions. I'm not going to write them. One is that you have the limit as nm approaches infinity of a nm equals L. And if it's true that the limit as n approaches infinity of a n m, I guess I should write this a bit differently. If it's true that for fixed m, a n m approaches some limits, doesn't really matter what it is, I don't know, L1 as n approaches infinity. And if it's true that for fixed n, you have a n m approaches L2, say, as m goes to infinite. So if you have like two convergences in both variables if you fix the other variable, and you have double convergence, then you can conclude these two things, that the two iterated limits exist. And you can conclude that both of them are equal to L, which is the double limit. Boundedness and monotone should make sense. Like I think, bounded is pretty obvious. You have some m such that the absolute value is less than or equal to m for all pairs of values. And increasing or decreasing works pairwise as well, right? Of course, if it's either increasing or decreasing, we say it's monotone. I think after writing this and thinking about it, I think the notation is kind of, like it's right, but it's maybe a bit misleading, because you've got like a less than here, and it's increasing, you've got a greater than here, and it's decreasing, but it's just because the ordering of my order pairs. If you like flip them, if you flip every sign, it's still work. Okay, yeah. I just kind of, for whatever reason in my head, I was thinking it through, and then it got backwards, and I should have fixed it.
Yeah, because the NM is less than the JK, but the NM comes before the JK.
Yeah, exactly. It's just kind of.
So is that like pairwise less than? Or is it like entry-wise?
It's n less than j, n less than j.
Yeah.
Okay. Yeah. Oh my god. And then now it's clicking down there. It's on now. My laptop's on, but that was strange. How the hell does that even happen? No. Something just like clicked down here and then maybe. I bet you. As long as it didn't fry my computer, then I don't care. I'll just say the last theorem because there was literally one thing left, which is monotone convergence theorem. It's literally what you would expect. Like a lot of this is kind of sensical. ANM, if you have that ANM is monotone and that ANM is bounded, then you get that ANM is, how do I write this? If it's bounded in both variables, which I guess I've already said, then the iterated limits exist and the double limit exists. So double lim exists and iterated limit exists. Limits, because there's two of them.
They're not necessarily the same unless we have the right.
Unless we have
like the three conditions.
Yeah, so if you have those three conditions, then yes, they're the same. But in general, they're not. Okay. Okay, let me pull up. I have notes on my phone about what I wanted to cover here. Screen's off now. That's scary. Oh, now it's good. I don't know what that was about. Let's see. So, first one I have here is, see, well, maybe I should do this. This might be the best way to go about this. Okay. All right, let me get a eraser out and we'll, I'll write it up on the board because I don't know the best way to go about this without slides. So the first one is constant row or column theorem. So theorem is, and I want you to try and prove it, of course. So you have a double sequence A and M. Should I write it properly? A and M is a double sequence. And then you have some, so it says, if for some k natural numbers, so you have k is a natural number, you have, the formatting is so bad, aij equals aik for all I and for all j less than equal to k. So after some point it just becomes constant going across a column or a row or however you want to think of it. Then two results. First one is that the limit as m approaches infinite of a n m exists for all n. And the second result is that the limit as m approaches infinite for a and m equals a and k for all n. It exists and it equals a and k, that constant value. I don't have answers to these, by the way. It's pretty straightforward.
I'm just copying that, but it looks like if the column is constant, then, yeah.
So you sort of just have to take this mess and translate it into definition of limit.
Is the first n equals 30 or not? So
M.
say n right now.
They're both them.
Okay, so it exists and further equals.
It equals, yeah. Yeah, maybe, I don't know. It's probably a better way to write that. I guess summatively, it's just that a and m approaches a and k as m approaches infinite for all n. Do I have anybody online? I don't even know. Let's see. Nope. Nobody wants to learn about double sequences. Very rightly so.
Did we show up last week?
Yeah,
Yeah.
lots of people.
Right after the midterm, I guess.
Right before.
Oh, right
Because the
before.
midterm was Wednesday.
Right, right, it was right before.
So I just spent that whole class answering their questions.
Yeah, I got stuck invigilating an exam. Technically, this is on my schedule, so I can't tell them
Yep.
no.
Yep. Yep. It's hard. I mean, technically, this isn't on my schedule either, but yeah. It's interesting though, as if you end up like specializing in any way, as you go further in math, you kind of just like can say no to things much more easily, right? Like it was like Mihai wanted me to teach discrete, and there's not a whole lot of people who can or want to teach discrete, right? Because one, it's a really hard course to teach, and two, it's just I don't know, it's not a lot of people know it that well, right? And so I should leave that on. Anyways, he was like, "Oh, can you teach Friday night?" Nope, I cannot.
Yeah.
I'm busy. And he was basically like, "Well, Marion can't teach Friday nights either, because he has some like, he lives in like Richmond Hill or something, and he's like, he goes to the Richmond Hill town hall meetings or something Friday nights or something. It's a very Marion thing to do." And so he was like, "Oh yeah, you can't." And I was like, "Well, then I'm not teaching." It's like, that I'm not doing any of it. I mean, it's not that I want to do things Friday nights, but I curl Friday nights. Like, I'm not.
Are you curl?
Yeah, I do. I've been curling for years.
My parents curl.
It's fun. It's great stuff, man.
They kept trying to get me to do it. I just
Yeah.
never did.
It makes sense. It's not for everyone, but
Well, they wanted me to go to the Learn to Curl event, so I don't want to go learn to curl with a bunch of 12-year-olds.
yeah, sure.
So-
Sure. Where do they curl?
Back in St. Catharines,
Okay. Yeah.
at the St. Catharines Curling Club.
Sure.
We only have one.
Yeah. Makes sense. It's a cool sport, but it's shockingly difficult. And it's very strategically deep, is what I'm trying to say. Yeah. So I'm like, yeah, I'm not curling so that I can get stuff.
I think I'm not
Yeah, probably. It's pretty easy.
by the supposition that A and M become A and K, right?
Yeah.
And then it's just A and K minus A and K in the limit, or in the absolute value if you go to the definition.
Yep.
So 0 is less than epsilon by
Yep.
how we define epsilon. So it's
Yeah.
the limit is A and K, so the limit must exist.
Yep. Yeah, you got it. It's straightforward. Let me get my next question.
And for that one, can we say because that we've looked at a constant column, right?
Yep. Well,
Do we
yeah.
say without loss of generality?
Yeah.
Both for rows because we can just switch the numbers.
Yeah. Nothing changes, right?
I was so happy when I got to write without loss of generality on my assignment.
Yep. Yeah. What question was that for?
It was for the rational one, show n to the q is an algebraic number.
Yep. Okay.
I said without loss of generality, assume s is positive.
Yep. Yeah.
Just
You can
make
just,
it easy.
yep, exactly, yeah. It's nice, it's a great feeling when you can finally use that. But-
Like, do a lot of people like mess up that question and not consider t less than 0?
Yeah.
They messed that up. Anyway.
And they all argued with me about it. And I was like, yeah, but like,
Yeah.
it has to be integer coefficients. And they're like, well, why wouldn't it be an integer I'm like, because it's a negative exponent.
Yeah.
You can have a negative exponent, and then what? You blow shit up.
That was another one of the errors I caught at like 10 o'clock.
Great.
So,
Zero product. So you've got a double sequence, A and M.
sorry, I'm getting a call from my bank.
Yeah, go take
I'm just
it.
gonna
I'll
go-
write this up. and
Yeah,
then-
I'm just gonna go get told I am pre-approved for a line of credit and I'll be back.
Great, sounds good.
Hello?
Did you get approved?
They wanted to give me, accidental death insurance this time.
Yeah, that's what they do.
Like, I'm not interested, cause it's a 5-year complimentary.
Of course.
I'm 20, you know I'm not dying in the next 5 years, you just want me to
Hopefully.
forget about it and start paying. Like,
Yeah. This is worded terribly. Where D and is A and N. There's the question. I'm just writing another one out. Which one is better? think a diagram might be useful for the whole convergence thing, the limits. That I just sort of thought up. But so for the because it feels like the difference between a double limit and an iterated limit is kind of the same thing. Like they kind of feel trivially the same. And then same thing with like these limits where it's like, you know, like they just feel similar. But the iterated limits are like this. That's one of them. That's the other. And then the double limit is this. If that helps you at all. Probably not.
Kind of.
Yeah. It's like you do the limit one way, do the limit the other way versus just going diagonally across. Right? What's your idea for the zero product theorem?
It looks very similar to, I think it's Eastern cartoon.
Maybe.
I think so. Yeah, very, very similar. So I'm kind of just working similar to the proof on that.
Okay.
Cn is bounded,
Yep.
so in the absolute value, you can say that, the absolute value of the product is multiplicative.
The absolute value.
The absolute
Yep.
value is multiplicative.
Yep.
And then we know that the absolute value of Cm is less than or equal to m.
Yep.
So we make that replacement.
Mhm.
And then I'm just scribbling out now the part where Bn is approaching 0. So it's going towards 0 times n.
Yeah.
So you pick, like Bn is less than epsilon for some n naught. So pick n is epsilon.
Yep.
No, not quite n naught, I don't think. It would have to be n naught. It's gonna be based on n.
Well, I think you can use the fact that Cm is bounded. That should tell you something about the limit as, let me double check my notes here. It should tell you something about the limit as m goes to infinity, or I guess the limit as m goes to infinity of a n m. And you can conclude, there's like a conclusion here that this is bounded.
Do I need that?
I think it helps. You might not.
I think I'm done.
Are you? This is a sequence. What'd you get?
It's true.
It is true. Yes.
When you write, when you're showing that oh no, that's not the double limit. That's what,
This is not the double limit.
yeah, I'm not sure, I did the double limit, which is not the same thing.
Nope, not necessarily. Happens.
Yeah. So, yeah.
So let's limit as it would be bn times the limit as m goes to infinite of cn. We don't know if that limit exists, so where would my solutions say? We'll go from there. So we don't know that this exists, this limit, because all we know is that it's bounded, and it could oscillate. But for fixed n and any m1 and m2 in n, we know that the absolute value of a n with m1 minus a n with m2 is less than or equal to the absolute value of bn times 2n. Does that make sense? In this case, it should be c. I guess I'll just change this limit to m just for fun. Or this band. So if we so I think if we do the difference, they're both bounded by m. The n's are constant or fixed. Why don't we say that means that a n m is Cauchy. And then by completeness, you get that the limit as m approaches infinite of a n m exists. Just by properties of the little sequences. So let's call that limit Ln. It's a sequence. The limit as n goes to infinite of a n m. Now we show that the limit as n goes to infinite of that sequence of L's is 0. So fix some epsilon greater than 0, then we know that the limit as n goes to infinite of bn is equal to 0. So that means that there exists an n such that absolute value of bn is less than epsilon over m, because bn converges. And so from that, and this is for all n greater than or equal to big N. Because of that, let's see, so for any, this is for any n greater than or equal to n, Ln is equal to the limit as m approaches infinite a and m, that's our definition, which is equal to the limit as m approaches infinite of b n c m. which is equal to the limit, actually I should write this properly, Bn times the limit as m goes to infinite of Cm, since Bn is constant with respect to m. And then from that, we get that this is less than or equal to Bn times m, which is less than or equal to, I guess strictly less than epsilon over m times m, which is epsilon. Boom. Does that make sense?
Yeah.
Good. Okay. Just sort of building the two parts. The Cauchy gave us this sequence, and then we were able to play with the definition of convergence on that to bound that Bn to give us that. I have two questions here: diagonal sets, or sorry, sequences, and proving monotone convergence for double sequences, whichever one you prefer. This one's a prove or disprove. I wrote that horribly. I'm just gonna fix it for niceness. You have a sequence D, N, N, R, N. And maybe for the sake of the camera, I'll show this side off a little bit better. The proof from that. People can read it online. But it's actually online. I don't think so. Yeah, nobody joins online anymore. Don't know why you can do it. Okay.
This is independence A and M, the double convergence means that M and N have to be greater than or equal to the big M.
The big M?
The big M, like in the definition of the double
Oh,
convergence.
yeah.
That element of calculus.
Yep.
Yeah, I'm gonna start relating the A and M to A and N. I feel like there's some. it's
Try
either
a
not true or
contradiction.
Some quality I'm missing.
Try a contradiction. There's a couple ways you can do the contradiction. I think you could pick an actual sequence. There's a few simple sequences that will work. Or you can use the definition. Consider directionality, which you might sort of have a feeling of from Calc 3. So, maybe consider the sequence. Question was what dn is a n, which is n over n, which is 1. But so it is true that like the limit as n approaches infinite of a n, n, which is just basically 0 as n approaches infinite of a n. It's true that that's like, right? It's obviously true that the limit as d approaches infinite, n approaches infinite is 0. But what about this? Okay. What about this? Yeah. How is it possible to show different limits? If this is actually the limit, then it should be the limit no matter which path you took to get to infinity. Right? Shouldn't matter. Yeah. Limit's a limit. So the limit can't be 1. Because it's sort of like this, you can take
a straight path, take some other path. This is sort of these logs. But still, like, you should get to the same limit, and if you get to different limits, then you have a problem. Right? False, it is false. How are we doing for time?
10 minutes. Sure. Yeah, want to try proving MCT? It is true.
Yeah, no, I believe it's true.
Yeah, it's very true.
On the board, it's almost zero.
Yep.
But
I think the iterated limits is easy. I feel like just because you're doing limits, right, single limits, the iterated is pretty easy. It's bounded. So, just doing the iterated limits first, so, for fixed n, you can just, look at this inside limit, right? And if n is fixed, then really this a n m is some sequence b n, or sorry, b m. Right? So this is really just the limit of b m. That's a terrible one. But since A N M is monotone, B M is monotone, and so bounded, right? If A N M is bounded, then B M obviously has to be bounded. So this is monotone and bounded. So the limit exists, call it B.
Right, like normal monotone convergence, right?
Yeah, this is just a normal sequence. And then, but since we're fixing n, really this should be d n, right? Because it's gonna be a different limit for each n. So then you're left with limit as n approaches infinite of b n, right? Which is, so can we argue that b n is monotone? I think we can, right? So if we know that A and M, I just said increasing with a loss of generality. If we know that this is greater than since this is a greater than or equal to, you can sort of think of this as limit as I approaches infinite, I and j is greater than or equal to the limit as, did I do this wrong? Yeah, I did. It should be I with limit as j goes to infinite of j with, or is greater than or equal to the limit of, or n with the limit as j goes to infinite of j. So really, this is equivalent to I is greater than or equal to j. One second. So, if this is true, then this is true. And we're taking the limits to be the case. And if we're taking the limits, then these just become bi is greater than or equal to bn. So bn is increasing monotone. Is it bounded? Well, it has to be bounded too, right? Just because we're dealing with a limiting case, like the n is still bounded, right? So this is bounded and monotone. So this is some L. So that was the iterative limits. The double limits. How the hell do we do double limits? So we want to show that with double limit, we want to show that for all n m greater than or equal to n, I guess I'm just going to do epsilon greater than 0 and natural numbers, then for all n m greater than or equal to n, the absolute difference between a and m minus l is less than epsilon for psi l. So we have that. How do we do it? And maybe I should like have clarified with that diagonal piece. This might be helpful. On that diagonal example, you could just pick n equals n and n equals 2n, and this condition is satisfied, right? So that's why you can do that weird stuff. So here, how do we go from here? So, well, if this is true, well, we don't know if that's true. But we do know that we can say, for example, that a n m approaches some b as bn as m approaches infinite, and we can say that a n m approaches some cm as n approaches infinite. Does that solve our thing? So that means we can do the bn minus, I guess that a n m minus bn is less than epsilon. And that a n m minus c m is less than epsilon. I don't know. You see anything for the double limits?
My first thought was triangle inequality, but I don't think that's applicable here.
Well, it's applicable, but does it do anything? Does it help at all? Yeah. Let's try it. A n m minus b n. This here is the same thing as c m minus a n m. So if we do this, does that help us at all? It does, no, it doesn't help us, does it? Well, 2an, or, yeah, 2an converges, then an has to converge. So can we just do like this? A n m minus c n. So this is greater than or equal to, well, this itself, let's say it's greater than, some epsilon, or less than some epsilon. Then we get triangle inequality says, two a n m plus some mess. Minus b and minus c m. So I think that means we can do this, which is terrible, but probably will work. Which, does it tell us that this is our L, our double limit? I think it does. If you take the limit of those two, as n goes to infinite, as c goes to infinite, which we know exists because of this argument here. So you can say for sure that the limit as n goes to infinite of b n is some, let's just say e, and the limit as n goes to infinite of c m is some c. So then this thing is equal to, or the limit of it is n is 1/2 b plus c. So the limit should be 1/2 b plus c, the average of b and c is the double limit, which should make sense, right? It's approaching infinitely from both directions. Does that seem right?
Yeah.
Good. Cause I don't wanna think about it anymore. There's double limits, or double sequences. Any questions?
Will this be on the test?
No.